What's up? I'm Vin, and today I want to go through the New York State 2022 math test for grade 6, and these are just the release questions. I'll leave a link to a copy of this test in the description below. So first up here, we want to know which value of m makes this inequality true, and we have 3m minus 4 is less than 11. So we could solve this by just plugging in values. Like let's say we let m equal 4, choice A, and we do 3 times 4 minus 4 is less than 11. And if we work this out, this would give us 12 minus 4 is less than 11, and 12 minus 4 is 8. So we'd have 8 is less than 11, which is a true statement. So right away I can see that choice A is correct. But if we want a more direct way of doing this, let's say we had to do this not using the answer choices, what we could do is we could do the algebra here. So if we want to solve for m, the opposite of minus 4 would be to look at doing plus 4 to both sides. So I could do that to both sides here. Minus 4 plus 4 will cancel because those are matching opposites. And now you have 3m is less than 11 plus 4 is 15. And then to get rid of times 3, we do the opposite, which would be to divide by 3. But we're going to want to do that to both sides. And now 3 divided by 3 cancels. And you have m is going to be less than 15 divided by 3 is 5. So we have m is less than 5. And if you notice, the only answer choice that is less than 5 is 4. So that's another reason why choice A is our answer. So that's our solution to question 1. So question 2, we have a farmer places beehives containing bees in her orchard to pollinate the plants. The table below shows the ratio, that's the $1 million phrase right there, of the number of beehives to the number of acres in the orchard. And the bees pollinate the plants at a constant rate. How many acres will be pollinated by bees and 18 beehives? So for this one here, we're told that this ratio is maintained all throughout the table. So that ratio of 3 to 8 is maintained for each of these entries. And one way we could see that is, let's say I take 9 over 24, that second entry, and I divide the top and bottom here by 3. Notice that this reduces to 3/8, which would correspond to that first ratio. So if I want to find the missing entry here, let's take 3 over 8 and think about how could I build 18 over this mystery value. Well, to get from here to here, I could go times 6. 3 times 6 would give me 18. So if I want to find the missing entry here, if I do times 6 on the bottom, 8 times 6 would give me 48 like this. So the missing value here is going to be 48. Now, I don't have to use the first entry. Let's say instead I wanted to use 9 over 24. If I want to go from 9 over 24 to 18 over the mystery value, notice here I would have to do 9 times 2. And if I did times 2 on top, I'd have to do times 2 on bottom. And that would also give me the mystery value of 48. So choice D is definitely our solution. So question 3, we have the net of a rectangular prism shown below. And we want to know what is the surface area in square centimeters of the rectangular prism. So for this one here, it helps to know what a rectangular prism should look like when it's all folded up. So a rectangular prism should look something like this. So you have to kind of imagine that when you fold this shape here along the dotted lines, that it's going to build something that looks like this. And if our goal is to find the surface area, that means we need to be able to find what is the length, what is the width, and what is the height of this rectangular prism. So the length, I would say, is this side here. I mean, technically we could twist this box and put it on its short side here, and we could say the length, width, and height is any one of those numbers, but let's just say the length is 8 centimeters like this. So going along this way, we'll say that's the longest side. And then the width would be this piece here going backwards from the length. And in this situation here, I would say that that's the 5 centimeters. So 5 centimeters. But once again, this is a little bit more forgiving. You don't have to say length is 8 centimeters to get this correct. You just have to identify what is the length, width, and height. And in this case here, the length, width, and height are all different. They're going to be 8, 3, and 5, just spread out amongst these variables here. But you could imagine here that when this is folded up along the dotted line, that the 3 centimeters is going straight up in the air. It's kind of like rotating upwards to make it go in this direction here. So that's why I'm labeling this as I did. So we're going to say the length is 8 centimeters, the width is 5 centimeters, and the height is 3 centimeters. Now, one thing to notice is that when you're finding surface area, the front and the back of a rectangular prism have the same area. And for the front and the back, you can notice here that it's going to be the length times the height that makes the front and the back. So we're going to have 2 identical faces. So I'm going to have 2 times length times height. Plus, I'm also going to have a left and a right like this. And the left and right are built by the width and the height. So I'm going to have 2 times W times H. And then the last component here would be the top and the bottom. And the top and the bottom is built by multiplying the length times the width. So I'd have 2 times length times width. And using this formula here would tell us the surface area of a rectangular prism. So now I just have to plug everything in. And because this is multiple choice, I'm not going to worry about the units until the end. I'm just going to plug in the numbers. So I'm going to have 2 times the length is 8 times the height is 3. And then I'm adding 2 times the width is 5 times the height is 3. And once again, I'm going to attach the square centimeters at the end. And then for the last component, we have 2 times length times width. So I have 2 times the length is 8 and the width is 5. So now just do the arithmetic. We have 8 times 3 is going to give us 24, times 2 is 48, plus 2 times 5 is 10, times 3 is 30. Let's just make that a little neater. And then we have the last piece here. I'd rather do 2 times 5 is 10, and then 10 times 8 is 80. And now when we add all this stuff up, well, 48 plus 30 is going to give us 78, and 78 plus 80 is going to give us 158. So choice C is our solution. We have 158 square centimeters. So question 4, Jake takes guitar lessons that cost $120 per month. We want to know which equation can be used to determine the total number of dollars D that Jake pays for lessons for any number of months M. So for this one, if you could just do that algebra in your head, then great. But what I tell students to do if they struggle with questions like this is to make a chart. Let's say I want to make a chart that tells me the relationship between the number of months that Jake takes guitar lessons and D, the total bill. So remember, M represents, it helps to label it, represents months, and D represents the total amount in dollars. So that way we know what each variable means. So let's say Jake only does 1 month of guitar lessons. Well, he's spending $120 per month. So that means his total bill would be $120. Now let's say he does 2 months. Well, then you would do 120 plus 120, or 120 times 2, which would be $240. And let's say that Jake does 3 months of guitar lessons, add another 120 to the bill, and that would be $360. So now think about what's the relationship? How could I get from this column to this column with one operation? Well, to get from here to here, I could just do times 120. So looking at the answer choices, I could say that column D is equal to whatever we have in column M just multiplied by 120. So I could say 120 times column M gives me column D. And that's why choice A is our solution. Question 5, we have Claire has 6 large envelopes and 11 small envelopes. What is the ratio of large envelopes to the total number of envelopes? So for this one here, if you go very, very fast, you might just say, oh, the ratio is going to be 6 to 11. So choice B. But no, be careful. This is a very dangerous bear trap, okay? We are not going with this answer choice because 6 represents the number of large envelopes and 11 represents the number of small envelopes. So this would be the ratio of large to small, not large to total. So the first thing you should find is how many envelopes does Claire have in total? Well, she has 6 large plus 11 small, which would equal 17 envelopes in total. So the ratio we want to set up is large to total. So large, there's 6, and in total, there's 17. So 6 to 17 is the ratio we want. Choice C. Question 11, what is the value of the expression shown below when x equals 7? So for this, just plug in 7. You're going to have 3 times 7 squared minus 2 times 7 plus 3. And for this, you just have to know order of operations. PEMDAS, a fun way to remember this. Please excuse my dear Aunt Sally, but this tells you the order in which to do your operations. So first, you're going to do parentheses exponents. So when I look here, I have a parenthesis 7 to the second power. So I'm going to do 7 to the second power, and 7 times 7 is 49. So I have 3 times 49 minus 2 times 7, and then plus 3. Now the next operations to look out for is multiplication and division. And notice that we have multiplication here, 3 times 49, and we also have 2 times 7. So 3 times 49, I know that's 147. If you want a little mental math trick here, you could do the long multiplication on the side. But when I do 3 times 49, I'm really doing 3 times 50 minus 1 in my head. And I just use the distributive property. I say, well, that's 150 and then minus 3, and that's where I'm getting the 147 from. And now here I have minus 2 times 7, so I have minus 2 times 7 is 14. And then I tack on the 3. Now, this is the part where students get tripped up. They say, oh, addition before subtraction, but just know that these two have the same rank. So when all you have left is addition and subtraction, just go from left to right and you'll get this correct. So what I'll do first is 147 minus 14. And that's going to give me 7 minus 4 is 3, 4 minus 1 is 3. I get 133. And now I just tack on my plus 3 at the end, and 133 plus 3 is 136. Choice C is our answer. Question 12, we have a partially shaded rectangle shown below. We want to know what is the area in square centimeters of the shaded part of the rectangle. So for this one here, we have a rectangle and the area is length times width. But the area of the shaded region is going to be half of the area of the rectangle, because notice that we're just connecting the opposite corners here. We're drawing in a diagonal. So that's going to cut the area in half. Notice that we have two triangles that are exactly the same. We could say the two triangles here, a fancy word would be to say that they're congruent, but these two triangles have equal area. So they're cutting the rectangle directly in half. So what I could do here is just multiply and divide by 2. So I'm going to have the area of the shaded region is equal to 8 times 14, and then I'm going to divide by 2. Now, I could do 8 times 14 first, or if I want to be really fancy, I could do 14 divided by 2 is 7, and then I could do 8 times 7 is 56. So that would tell me that the area is going to be 56 square centimeters. Choice C is our answer. So take a second to read through question 15. Now, my mindset for this question is I'm thinking proportions here. And I'm thinking, let's think about the part over the whole. So for this one, we have 10 science club students that are on a field trip. And the number of students represents 20% of the total number of students in the science club. We want to know what is the total number of students in the science club. So once again, the theme is part over whole, and we're going to set up a proportion. So the group of 10 students that are on the trip just represents some of the students that are in the science club. The total number of students, what we're looking for, we're going to call X. So 10 on top is going to represent the part, and X on bottom represents the whole, which is the total number of students. And we're going to set this equal to 20% because we're told only 20% of the students in the club went on the trip. So 20% is the same thing as 20 out of 100. And if I chop out these common zeros, I could say this is equal to 2 over 10. And that, if I divide the top and bottom by 2, is equal to 1/5. So I'm going to set this equal to 1 over 5 here. I'm just going to reduce the percent, 20%, to 1 out of 5. So once again, I'm setting up a proportion here. So we're looking at part over whole for the percent is going to be 1 out of 5. So now to solve for X, all I have to do is cross multiply. I'm going to have X times 1 is X. And this is equal to 5 times 10, which is going to be 50. So this is going to tell us right away that choice C is our solution. So before we move on, I want to look at another option on how to solve this. So if we took 20% and wrote it as a decimal, 0.20, which I could even just say is 0.2, I can multiply every answer choice by 0.2 and see that it gives me 10. So let's say choice A, if I were to do 20 times 0.2, this would give me 4, which is not equal to 10. So that's why this is out. If I took choice B and I did 30 times 20% or 0.2, this would give me 6, which once again does not match 10, so this choice is out. If I take the correct answer choice and I multiply 50 by 0.2, that's going to give me 10. So that's how I know for sure this is right. But if I took 20% of 80, I do 80 times 0.2. This would give me 16, which once again is not equal to 10. So choice C is definitely good. Now, question 16, we could just plug in the values of X to see which of them make this equation true. That will work, or we could just solve this algebraically. So I'm going to take 4x minus 8 equals 4, and I'm going to do the opposite operations until X is by itself. So the opposite of minus 8 would be to do plus 8. But if I do that to the left side, I have to do that to the right side. And now minus 8 plus 8 cancels. I have 4x left on the left side of the equal sign, and on the right side of the equal sign, now we have 4 plus 8, which is equal to 12. So now, how is 4 attached to X? Well, 4 is attached by multiplication, and the opposite of multiplication is division, so I would divide both sides by 4. 4 divided by 4 would cancel, and I would have X equals 12 divided by 4 is equal to 3. So choice B is definitely our solution. Well, what I could also do to make sure that this is right, I could plug X equals 3 back into the original equation, and I would have 4 times X equals 3 minus 8, and that should be equal to 4. And if I do 4 times 3, that's 12. 12 minus 8 equals 4, and that is a true statement because 12 minus 8 equals 4, and 4 equals 4 is definitely true. So choice B. So question 17, we have employees at a construction company are building a fence around the perimeter of a work site. The perimeter of the worksite is 1/4 of a mile, and we are told the cost of fence is $20 per yard. What is the total cost of fence needed for the perimeter of the worksite? Well, one thing to be careful with right away is that the perimeter is given to us in miles, and the cost of the fence is given to us per yard. So one thing you would want to know here is how many yards are there in 1/4 of a mile? Well, if you go to the reference page, they tell you that in 1 mile, there is 1,760 yards. Okay, so this is just information that you could grab from the reference page, which is at the beginning of the test. So if I want to know how many yards there are in 1/4 of a mile, I could just divide both sides here by 4. So I'm dividing both sides by 4, and that tells us in 1/4 of a mile, there is 1,760 divided by 4 yards. And for that, I could just do the long division here on the side. If I divide by 4, 4 goes into 17 4 times. 4 times 4 is 16, so I subtract that. 17 minus 16 is 1, and I carry down the 6. 4 goes into 16 4 times. 4 times 4 is 16, and when I subtract, I get a remainder of 0. So when I bring down the 0, 4 goes into 0 0 times. 0 times 4 is 0, and when I subtract 0, I have no remainder. So this would tell me there's 440 yards. Now, we have to think about what to do with this information. So now let's consider the rate here. The rate over here, this rate is the cost of fence. It's $20 per yard. So if we have 440 yards of fence to cover, it's going to cost us $20 per yard. And if you think here, the units would cancel out. Yards on top would cancel out the yards on bottom. So that would tell us we would have 440 times 20. And for that, if I'm doing that in my head, 44 times 2 is 88, and I have 2 extra zeros, so it'd be 8,800 like this. So I'm seeing right away that this is going to cost $8,800. Choice B would be our solution. So Ralph has 3/4 of a gallon of paint, and he wants to store all of the paint equally among 5 containers. And be mindful, he's storing the paint equally. That's $1 million phrase right here. How much paint in gallons will Ralph store in each container? Well, since he's storing it equally in 5 containers, he's taking the 3/4 gallon of paint and he's dividing it by 5 into 5 containers. So now just call this 5/1, and we're going to use keep, change, flip. When you divide fractions, you could keep the first fraction, you change the operation to multiplication, and then you flip or find the reciprocal of the second fraction. And now just do 3 times 1 is 3. Over 4 times 5 is 20. So 3/20 is our solution, choice A. So question 23, we have a parallelogram is shown below. We want to know what is the area in square centimeters of the parallelogram. So for this one, it helps to know that the area of a parallelogram is base times height. Now, if you don't know that formula, the idea behind it is that let's say I were to drop down another altitude like this and chop this triangle off, and I move this triangle from here to here. What that would make is it would make a rectangle. And this rectangle, you see how this distance across I could call B. This rectangle would be, let's say, B length across this way, and the height would be the same since the altitude of a parallelogram doesn't change. The distance between parallel lines does not change. So you see how we would have a rectangle with dimensions B and H. That's why the area of a parallelogram is base times height. But now that we got the concept out of the way, let's just go ahead and use that idea for this question. So just know opposite sides of a parallelogram are equal in measure. So if this side up here is 4.25, I could say that this side over here is 4.25 centimeters. So I could say here that our base is 4.25 centimeters, but I'll leave the units out since the answer choices have no units. And then the height is the distance between the parallel lines. So the height here would be 2.8. So then all I have to do to find the area would be 4.25 times 2.8. And for this, I can make it 2.80. This part here is not really going to matter too much. So I would have 0 times 5 is 0. So for this first entry here, I'm just going to get a bunch of zeros. And then I put a placeholder here, and I'll invest in our future happiness and put 2 placeholders for the next row. And I would have 8 times 5 is 40. So I'd carry the 4. I have 8 times 2 is 16, plus 4 is 20. So I'm getting a whole lot of zeros here. And then I'd have 8 times 4 is 32, plus 4 is 34. So this is what we have here. So now for the next row, I'm going to use this 2, and I have 2 times, and let's get rid of these here so that you don't distract us. 2 times 5 is 10. So I get a 0 and I carry the 1. 2 times 2 is 4, plus 1 is 5. And I have 2 times 4 is 8. So now I'm going to add all this up. So these are easy. They're all zeros. And then this row I have 4 plus 5 is 9. And then 8 plus 3 is 11. And now just be mindful that I ignored 4 decimal places. So the fact that I ignored 1, 2, 3, 4 decimal places means I'm going to move the decimal 1, 2, 3, 4 places, which would tell me our solution is going to be 11.9. Choice C is our answer. So question 26, we just have to be skilled with the number line. We have the points Q, R, S, and T shown below. We want to know what point represents negative half. Well, negative half would be right between 0 and negative 1. So R would be our solution right away. Now, the reason why it's not Q is that Q is between negative 1 and negative 2. So that would be negative 1.5. If I wrote it as a decimal or as a fraction, I would say negative 3 over 2. So that's why this choice is out. S is no good because it's between 0 and positive 1. So this would be the mark of positive half like this. So that's why point S is out. And then point T is no good because that would be the location of 1.5, which I could also say is positive 3 over positive 2. So point T is out, so B is our solution. Question 27, we have Miss Wilson is buying packages of pencils, and each package costs $11.52 and contains 96 pencils. What is the unit price of a pencil? So unit means 1. So what we're really looking for here is how much does one pencil cost? So if it's $11.52 for 96 pencils, we want to find out how much does it cost for one pencil. So really what we're doing here, it's kind of like reducing a fraction, is we're dividing the top and bottom by 96. And this is going to tell us how much it costs for one pencil. Okay, so the cost per pencil like this. So we're dividing the top and bottom by 96. 96 divided by 96 is 1. So that's how it's telling us the cost of one pencil. So now I just have to do 1152 divided by 96. And that I'll just do on the side. So I have 1152 divided by 96. So now I could say 96 goes into 11 0 times. And now I could ask myself, how many times does 96 go into 115? And that's going to go in once, because what I'm imagining here is, and let's just draw a better thought bubble, is I'm imagining if I did 90 times 2, 90 times 2 is 180. 90 is less than 96. And if I were to go times 2, that would be too much. That would surpass 115. So 1 is going to fit the description here. And I'm going to do minus 96. So I borrow, make this a 0, put the 1 here. 15 minus 6 is 9. 10 minus 9 is 1. And now I bring this down. This is going to go in twice here. So this is looking like it's going in twice. But the worst that could happen is when I multiply by 2, it's going to give me a number more than this. And then I would have to try something else. So if you don't know how to do that in your head, that's fine. You can just do this on the side. You have 96 times 2. So 12, carry the 1. And then I have 2 times 9 is going to give us 18, plus 1 is going to give us 19. So this gives us 192 exactly. So this will simplify here. This is going to have no remainder. So this is going to work out to 12 cents per pencil, which is going to match choice A. So question 28, we have 3 vertices of a rectangle are located at 2, 4, negative 2, negative 5, negative 2, 4 on a coordinate plane. We want to know what are the coordinates of the 4th vertex of the rectangle. So for this, I would just sketch this out. And just know that when you sketch the coordinate plane, you have an X and Y axis, and your first coordinate is your X, your second coordinate is your Y. And the X tells you how much to move left and right. The Y tells you how much to move up and down. So the point 2, 4, I would go to the right 2 units, and I would go up 1, 2, 3, 4 like this. So I would go to the right 2, up 4. That would be my first point of my rectangle. Negative 2, negative 5 tells us to go to the left 2 and to go down 1, 2, 3, 4, 5 like this. So negative 2, negative 5 would be over here. And then negative 2, 4, I would go to the left 2 and up 1, 2, 3, 4 to this location. So the missing vertex is going to be somewhere over here because it's a rectangle. And remember, a rectangle looks something like this. Okay, opposite sides are equal in measure, and we have 4 right angles. So I could see the mystery value is going to be right over here. And if I had to label it, that's me going to the right 2 units and down 5 units. And when I go down along the y-axis, my y coordinate is negative. So my solution would be choice B, 2, negative 5. So question 32, we have there are red tiles and blue tiles in a box, and the ratio of red tiles to blue tiles is 3 to 5. There are 12 more blue tiles than red tiles in the box. We want to know how many red tiles are in the box. So for this one here, once again, the ratio of red to blue is 3 to 5. So this is the ratio of red to blue. So there is a few ways we could do this. One way is to do this algebraically. Algebraically is a little bit tricky, but what I recommend if you are doing it algebraically is to set up the ratio for red to blue, but just tack on an x. So just multiply both of these by x, because what this represents is any possible combination here of red to blue that would reduce to 3 to 5. Like let's say I had something like, I don't know, x equals 10. Then I would have 3 times 10 is 30. 5 times 10 is 50. And notice that 30 divided by 50 simplifies to 3 over 5. So it reduces back to 3 to 5. So just having this with x's allows us to work with situations like this. So what we know is that there are 12 more blue tiles than red tiles. So what that would tell me is that if I took 3x and I were to add 12 to it, then that would give us the exact amount of blue tiles there are. So once again, the ratio is 3 to 5, but if I add 12 to this value, it's going to equal the 5x value next to it. So then if we just do this algebra, minus 3x on both sides, and what this is going to give us is we're going to have 12 is equal to, because 3x minus 3x cancels, 12 equals 5x minus 3x is 2x. And then just divide both sides by 2. And then 2 divided by 2 cancels, which tells me that x equals 12 divided by 2 is 6. But be careful. 6 is obviously, it's not an answer choice. So we couldn't even fall in that trap if we wanted to. So what you have to do then is plug 6 in for x. And that tells us the ratio of red to blue. So we have the ratio of red to blue is going to be 3 times 6 is 18 to 5 times 6 is going to give us 30. So what we have here, how many red tiles are in the box? There are 18 red tiles in this box. Now, another way to do this would be to just try values out. So let's say I make a column here for red and blue, and I start with the standard ratio 3 to 5. Now, let's say I multiply this by 2. I would get 6 and I would get 10. But then ask yourself, is 10 12 more than 6? And that answer is no. So I would keep going. I would say, all right, how about 3 times instead of 2, 3 times 3? And that would give me 9. And if I did 5 times 3, that would give me 15. And notice, still, this is not 12 more. 15 is not 12 more than 9, so this wouldn't work. So I don't just have to keep doing this over and over. 3 times 4 would give me 12. 5 times 4 would give me 20. And I'd have to keep going here. If I did times 5, I would get 15. 5 times 5 is 25. But notice these are 10 away, not 12 away. And then finally, I do it once more. 3 times 6 would give me 18. 5 times 6 would give me 30. And notice these two are definitely 12 away from each other. So this would be the mystery pair here. There would be 18 red tiles. Choice A is still our answer. So for question 33, we want to know what is the surface area in square inches of the rectangular prism formed by folding the net below. So for this one here, just imagine we fold this along the dotted lines. It would form a rectangular prism that looks something like this. So now we just want to translate these values over to this shape here. Well, we could say the length is the long side. We'll call that 36 inches. Now the width we could say is 23 inches, and the height we could say is 8 inches. So these are just our labels here. This is our length, this is our width, and this is our height over here, 8 inches. And remember from before, the surface area we said was 2 times length. So let me just make that a little bit neater. So we have 2 times length times width, plus I would have 2 times length times height, and I could say plus 2 times, and we could say width times height like this. Now, just know multiplication and addition are commutative. So this doesn't exactly match what we had written earlier. So that's a formula I just don't have memorized. What I do know, though, is that in a rectangular prism, which I mentioned earlier, that there are 6 faces to it. There's a front and a back, which have equal area. There's a left and a right, which have equal area. And there's a top and a bottom. So you're basically just finding the area of 6 rectangles and adding them all together. But remember, each pair of rectangles that are opposite each other have the same area. So that's why we're just doubling those. So that's the idea behind that formula. So now I would just plug in, I would have the surface area equals 2 times the length, and I'm not going to write the units. I'm going to say 2 times 36 times the width is 23, plus I would have 2 times the length is 36 times the height is 8, plus 2 times the width is 23 times the height is 8. And this, once again, we get a basic calculator, so this I would just type in. So now let's just type this in. So I'd have 2 times 36 times 23, and then I'm going to add, we have 2 times 36, and we're multiplying that by 8, and then we're going to add one last product. We have 2 times 23 times 8 like this. Now, if your calculator can't type everything in one shot, then I would do these products one by one, and then I would add those three terms together. But this, I can just do it all at once, and this would work out to 2,600. So the surface area, once again, works out to 2,600, and we're talking about square inches here, and that would match up with choice D. Question 34, Jasmine goes to a store to buy some fruit to make a fruit salad, and the list below shows the amount and the price of each type of fruit that she buys. So here's all the information that we need, but we want to know which type of fruit costs $1.55 per pound. So the theme for this question is that we're looking for the unit rate for all of these fruits. So one that I could eliminate right away, just looking at this, is grapes. That's probably the easiest one to do in your head. You take $4.80 for 2 pounds of grapes, and if you do 480 divided by 2, that would reduce to $2.40 per pound. So this would be the unit rate, and that doesn't match the $1.55. So that's how I know grapes are out. So this one is gone. The next one I could eliminate would be the third one. So looking at oranges, it's $7.50 for 5 pounds. And if I were to divide 750 over 5, that would tell me that oranges are $1.50 per pound. Now, I'm able to do that math in my head because I played a lot of Monopoly as a kid. That is a great game to play if you want to get better at mental math. The key is that you got to be banker, and you can't use the electronic banking. You got to just practice doing this. So that's how you get quick with this kind of mental math. And now the answer choice that I could see right away, because now that oranges are out, this last choice is looking good, but I would just do the division to be 100% sure. So if we want to divide here, what we're going to have is we're going to do 465, and we're dividing this by 3, okay? Because we're going to be reducing $4.65 for 3 pounds to find out what is the unit rate. So 3 goes into 4 once, and 1 times 3 is 3. So I'm doing minus 3, which gives me 1. And now I'm going to line up the decimal here, and I'm going to bring this down. So I'm bringing down the 6. 3 goes into 16 5 times. 5 times 3 is 15. And now subtract, you have a remainder of 1. And now you're going to bring this 5 way down here. And 3 goes into 15 5 times, and 5 times 3 is 15, so we have no remainder like this. So $1.55 per pound corresponds to peaches. Okay, so when we reduce this one here, the unit rate is $1.55 per pound. Choice D is our answer. So question 35, the outside temperature in a town is negative 20 degrees Fahrenheit. Wow, that is dangerously cold. So what change in temperature in degrees Fahrenheit would bring the outside temperature to 0? So what I'm imagining here is, just imagine you have a thermometer, and here's 0, here's all the positive stuff. So positive is going this way, and negative is going this way. So we're starting at negative 20. Okay, so we're starting, let's say, all the way down here at negative 20. So what change would bring us back to 0? Well, we have to move back in the positive direction here. So we would have to go plus 20 degrees to go back to 0. Because if you think about it, we're starting here. So this is the start. So the start plus 20 is the change, equals the new temperature. And negative 20 plus 20, they're matching opposites, would give us the new temperature that we want, which we want it to be 0. So the change would have to be 20, which would match choice D. Question 36, a diagram of Joe's living room wall with a geometric design is shown. Joe painted the shaded triangle on the living room wall. What is the area in square feet of the shaded triangle that Joe painted? So the first thing you need to know here is that the area of a triangle, the formula, is 1/2 base times height. Now, the base we're going to use over here, the base we're going to say is 12 feet, because that's the one side of the triangle that we actually know. So the base is 12 feet. Now, the height is the distance from this point to the base, but remember, the line that I draw has to be 90 degrees to the base like this. So this has to be a 90-degree angle like this. But let's be mindful that this is Joe's living room wall, and it's a nice rectangle here. So the height of the triangle is going to be equal to the height of the wall, because notice that these lines are the same length. So I could say that the height here of the triangle is going to be 8 feet. Okay, so that is the height of the triangle, 8 feet. So now I just use the formula. The area of the shaded triangle is going to be 1/2 times the base is 12 feet, and I'll put the units in at the end. So 12 feet times 8 feet. And now just multiply everything. We have the area of the triangle equals 1/2 times 12 is going to give us 6, and we're going to have 6 times 8 is equal to 48. So the area of the shaded triangle is 48 square feet. So choice C is our solution. So we have 640 students at a school on Friday, and the students either walk or take the bus to school. 45% of the total number of students walked, and we want to know how many of the students rode in a bus to the school. So let's think about the percent of students that walk to school versus the percentage of students that bus to school. Well, the percentage that walk to school, we were told, was 45% of the total students in school on Friday. And we have to think about, in total, there's 100% of the students. So if we do 100 minus 45, that'll tell us the missing percent, which represents the percent that took the bus. So 100 minus 45 is 55. So 55% of the students at school on Friday took the bus. So now the next thing you should know how to do here is 55% is 55 out of 100, which is equal to 0.55. So if we want to find out how many students rode the bus, take the total, 640, and you're multiplying that by 0.55. But now we're in the calculator section. So I'm just going to do 640 times 0.55, and this will give us our solution. So we have 352 students that took the bus. So this product was 352. So choice B, 352 students rode on the bus. Question 38, we have Josh has C coins and Nick has 4 fewer than 3 times as many coins as Josh. Which expression can be used to show how many coins Nick has? So for this one, you got to really take your time, because what students will do is they'll say, all right, 4 fewer than means subtract. 3 times means 3 multiplied by. The number of coins is Josh. Oh yeah, Josh has C coins. And they say 4 minus 3C, choice D. But no, be careful. This is a very dangerous bear trap, okay? When they say 4 fewer than 3 times as many, that tells you you have to switch these two, okay? This language is very tricky to decipher, but 4 fewer than 3 times as many tells us that we have to switch these. So the correct answer would be, we would have this somewhat in the expression here, but we'd have to switch these, and the actual answer would be 3C minus 4, which would actually match choice A. So question 39, we have 2 students, student A and student B, and they claim to know the correct representation of this expression here. And both students' claims are incorrect. And we want to know what makes each representation incorrect. And we actually have to explain our answer, which means we actually have to write a sentence here. So this expression is 9 divided by y times 3 times t. So let's look at student A. Student A represents the expression as the product of 9 and y. So right away I could see that this is a mistake, that 9 and y are not being multiplied. Product means multiply. What they're actually doing is dividing 9 and y. So we could say the quotient of 9 and y. So quotient would work, or we could say dividing 9 and y. That would be better to say, but we're finding the quotient of 9 and y, and then we're multiplying that by the product of 3 and t. So that is student A's mistake. Now, if we look at student B, they're saying the expression is the quotient of 9 and y. So that part is correct, times the sum of 3 and t. But notice 3 and t are not being added. They're being multiplied. So this word here, sum, needs to be changed to product in order for this to be correct. So now that we've identified both mistakes, now we just write our sentence. So question 40, we have a track coach creates an obstacle course for his team, and the coach plots the locations of 3 obstacles on the coordinate plane shown below. And each unit on the coordinate plane represents 3 yards. So this is telling us our scale here. And a student starts at obstacle A. So they're starting here, and they're going south to obstacle B. So they're going this way first. So they're going here. And then after they get to obstacle B, they go west to obstacle C. So then they're going here. So I know I'm drawing it from going left to right, but they're going from obstacle B this way to obstacle C. And we want to know what is the total distance in yards that the student runs to get from A to C. So for this one here, the first thing we should do is count the boxes. So they're going down 1, 2, 3, 4, 5, 6, 7. Now, let's say you're nervous with counting. Just know that they're going from 5 to -2. So if I did 5 minus -2, 5 minus -2 would also give me 7. So that's 7 units that they're going down like this. Because remember, each unit on the coordinate plane is represented by the x and y axis. So they're going 7 units in this direction. And then how many units are they going left and right? Well, they're going from 3 over to -7. So if I did 3 minus -7, that would be equal to 10 because this would change to 3 plus 7, which would give me 10. Or I could just count the boxes. I'm going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this distance is 10 units. But one thing to be mindful of is that 1 unit across is 3 yards. So if I want to find the total distance they run in yards, well, they're going 7 units, which is once again 3 yards. So 7 times 3 yards. Plus, they're going 10 units this way, but each unit is 3 yards. So now I just have to simplify things here. This is going to be 21 yards when I do 7 times 3 yards. So 21 yards plus 10 times 3 is 30 yards. And if I add those two together, 21 yards plus 30 yards is 51 yards. And this is our solution to question 40. Question 41, a restaurant owner orders new plates and spoons based on the information below. So we have plates are sold in packages of 9. So this is for plates, and spoons are sold in packages of 12. And the restaurant owner orders an equal number of plates and spoons. What is the least number of packages of plates and packages of spoons she should order to have an equal number of plates and spoons? So the concept behind this question, what jumps out at me right away, is least common multiple. So that's what I'm thinking here. So if I'm just thinking, and I don't know, that was a bad M. Let's try that again. So least common multiple is I'm thinking about plates. So for the plates, packages of 9 means if we buy 1 package, we get 9 plates. 2 packages, we have 9 plus 9 or 18, then 27, then 36, then 45, and so on. But when we think about spoons, spoons come in packages of 12. So that's 12, and then 2 packages would be 24, 3 packages would be 36, then 48, and so on. But the goal is to have an equal number. So let's try that again. An equal number of plates and spoons. So the equal number, the first time that these are equal is at 36. So that's what's jumping out at me right away. But the actual question is, what is the least number of packages of plates and spoons she should order to have an equal number of plates and spoons? So now we are ready to record our answer. That would be 1, 2, 3, 4 packages of plates, and that would be 3 packages of spoons. And if we wanted to double check here, once again, the plates come in packs of 9, so we could say 4 times 9 is equal to 36. This checks out. And if we were to check here, 3 packages times 12 spoons would give us 36 spoons. That checks out. So these solutions are definitely good. Question 42, I have a cereal box that has these dimensions here and a pastry box with these dimensions here. And we want to know what is the difference in volume in cubic inches between the two boxes. Well, for this, we have to know that the volume of a rectangular prism is length times width times height. So for this one here, I would say the volume of the cereal box is going to be, the length is 12 inches. So I have 12 inches times the width is 7 3/4 inches. But just know 3/4 is the same thing as 0.75. Because think this is 3/4, and 3/4 is worth 75 cents. That's one way to remember it. So I could write that as 7.75 inches. And now I'm going to multiply that by 2 inches. So this I could just use a calculator for. I'm going to do 12 times 7.75 times 2. So let's just multiply that out. We have 12 times, we have 7.75, and then we're multiplying that by 2. And this is going to work out to 186. So the volume of the cereal box is 186 cubic inches like this. So now the next thing I want to find is what is the volume of the pastry box. So I'll put a subscript P here to represent the volume of the pastry box. And that I would multiply the length, width, and height. So I'm going to multiply 3 2/3 by 3.5 times this. Now, the little bit of annoyance to this part is this is not easy to type into a calculator. So you might want to turn this into an improper fraction. So something like 3 2/3, I could turn into an improper fraction by multiplying. So let me just make that a little bit neater. So I'm taking 3 2/3, I'm multiplying 3 times 3, which is 9. And then I'm going to add here. So that product, 3 times 3, I'm going to add 2 to it. And I'm going to divide by the original denominator is 3. So I multiply these two numbers, so 3 times 3, and then I add the 2 on top. And that's going to give me 3 times 3 is 9, plus 2 is 11. So 3 2/3 is equal to 11/3. So I'm going to have 11/3 times, and now my next dimension is 3.5. So 3.5, I could say, is equal to, we multiply 3 times 2 is 6, plus the 1 on top gives me 7 over 2. So this is 7 halves like this, so times 7 halves. And then if I convert the last one, I'll just do that in my head. 3 times 2 is 6, plus 1 is 7, and I'm dividing by 3 this time. And the units here for volume, once again, is cubic inches. So this I could just multiply out in a calculator. But I'll leave that part up to you to check my work here. 11 times 7 times 7. So I'm just going to multiply the numerators across. 11 times 7 times 7 is going to work out to 539. And if I multiply 3 times 2 is 6. 6 times 3 is 18. And my units are cubic inches like this. And this one I'd actually want to simplify to a mixed number. So I'll just do that long division here on the side. If I do 539 divided by 18, I could say here that 18 goes into 53 twice. 2 times 18 is 36. And if I subtract here, I'm going to borrow and make this a 4. 13 minus 6 is 7, and 4 minus 3 is 1. And now I just bring this down here, and this is a 9. Now, what I have here is I know 18 times 10 is 180, and I just missed by 1. So that tells me 9 is as close as I'm going to get. And now I would just do 9 times 18. And 9 times 18, I could use a calculator, but I'll just do this on the side here. 9 times 18, that's going to give me a 2 from 72, and I carry the 7. And then 9 times 1 is 9, plus 7 is 16. So I'm subtracting 162 like this, and I have a remainder here of 17. So I'd have 29 and 17 over 18. So my remainder goes here under my original divisor here was 18. So that would give me my answer as a mixed number. So the volume of the pastry box is 29 and 17 over 18 cubic inches. So the task here was to find what is the difference in volume. So the difference I could find by subtracting these now. So the difference I would find by doing 186 minus 29 and 17 over 18. So this, if I work this out, notice that this is a mixed number and this is not a mixed number. So this is making it a little bit tricky to subtract, but what I could do here is I could rewrite 186 as 185 and 18 over 18. Because this would mean 185 plus 18 over 18 is 1, which would bring me right back to this. So I have minus 29 and 17 over 18. And now I just have to do the subtraction. So on the side here, I'll subtract the whole numbers. I have 185 minus 29. And when I subtract just the numbers I borrow here, 15 minus 9 is 6, 7 minus 2 is 5, and I carry down the 1. So this is going to give me 156. And then when I subtract the fraction part here, I have 18 minus 17 over 18 like this. So this is going to simplify to 156 and 1 over 18 like this. So my final answer simplified is 156 and 1/18 cubic inches. Question 43, 2 students evaluate this expression here, and here's their method explained. We want to know, is each student's evaluation correct or incorrect? And we have to explain our answer. So this time around, we have to determine if they're correct. So student A evaluated the expression by adding the product of 17 and 4 to the product of 17 and 15. Well, notice that student A just used the distributive property. That what they did was, once again, 17 times 4 plus 17 times 15. So that's the result of using the distributive property, which is a valid technique. Okay, this will work. So student A is correct. Student B evaluated by determining the product of 17 and 19. So what they did was they used order of operations here. So if we look at this, they used order of operations. They used PEMDAS here. Remember the mnemonic, please excuse my dear Aunt Sally. They did the operation inside the parentheses first, and then they chose to multiply. 4 plus 15 gives us 19. So both students are correct. Student A is correct because of the distributive property, and student B is correct because they followed order of operations. Question 44, Ryan is delivering flowers to 2 customers. He drives for 12 minutes at an average speed of 40 miles per hour to reach his first customer, and then he drives 15 minutes at an average speed of 50 miles per hour to reach his second customer. So during the 27 minutes of driving, how many total miles does Ryan drive? Now for this question, I think the easiest way to do this is to set up a proportion. So let's think about the first customer. And for the first customer, Ryan drove 40 miles per hour. But instead of writing per hour on bottom, I'm going to say 1 hour is 60 minutes. Now, I'm writing the hour in the form of 60 minutes because we're told that he drove for 12 minutes for the first customer. So that means when I set up the proportion here, I'm going to put the minutes on bottom. We have 12 minutes. So I want the units of time to match because that's what allows us to actually set up a proportion. And on top, the units have to match these units in terms of miles. So now how do you get from 60 to 12? If you're really quick with your mental math, you'll just say, oh, divide by 5. 60 divided by 5 is 12. So then if I just divide the top by 5, 40 divided by 5 is 8. So the mystery amount of miles for the first customer, Ryan drove 8 miles to get to the first customer. Now, if you can't do that mental math, just put an X here instead and cross multiply. So that's a very real possibility here. You just put an X and then you'd have to do 60 times X is equal to 40 times 12 would give you 480. And if you divide both sides by 60, this would also give you X is equal to 480 over 60 is also 8. All right, so you could solve it algebraically, but once again, I think it's much easier if you could do the mental math to just get right to it and divide to get the numbers to match. So 8 miles is the mystery amount of distance that Ryan drove to the first customer, but we want to find the total distance that he drove. So we also have to think about the second customer. And for the second customer here, let's think about this. Ryan drove a little faster. He drove 50 miles per hour. So 50 miles per hour, and once again, I'm writing an hour as 60 minutes. So that when we look at this next part here, that Ryan drove for a total of 15 minutes towards the second customer. This is going to allow us to solve for the mystery distance. So how do I get from 60 minutes to 15 minutes? I could divide this by 4. 60 divided by 4 is 15. So now I just divide the top by 4. And of course, this is not going to be something nice. If you want to do that in your head, though, you want to be really good at dividing things by 4, even when you're going to get a decimal, just divide it by 2 twice. So I'm really just doing like 50 divided by 2, and then like I'm dividing by 2 again. So 50 divided by 2 is 25. And when I divide that by 2, that's going to give me 12.5. Okay, so that's how I know the mystery amount of miles for the second part is going to be 12.5 miles like this. If you had to, though, of course, you could always just do 50 divided by 4 on the side like this, and then 4 goes into 5 once. If we subtract, we get 1, we carry this down. 4 goes into 10 twice. 4 times 2 is 8, and when we subtract, we get a remainder of 2, and this is 2 over 4. So 12 and 2/4 is the same thing as 12.5 or 12.5. So that's how I know this is definitely correct. But now for the total, what I'm going to do is I'm just going to add these two values together. So we have 8 plus 12.5, and the units here are miles. So the total distance that Ryan drove, if we do 8 plus 12.5, that's 20.5 miles. This is our solution to this question here. Question 45, Johnny is 21 years old. He is 3 times as old as Becky. We need to write and solve an equation. So that's the actual task to determine Becky's age A. So for this one here, what we have is we have Johnny, and Johnny is 21, and Becky is A years old. And this is the information that actually helps us set up the equation. We're told that Johnny is 3 times as old as Becky. That means if we take Becky's age and we multiply it by 3, that's going to give us Johnny's age. So here's our actual equation. And now to solve this equation for Becky's age, just divide both sides by 3, because the opposite of times 3 is to divide by 3, but now we got to do that to both sides. So 3 divided by 3 cancels, and A equals 21 divided by 3 is 7. So that, let's just make it a little bit neater. A equals 7 is Becky's age. And if you think about it, if you want to check this in your head before you move on, you take Becky's age, 7, and you multiply it by 3, and that's definitely equal to 21. So our answer checks out. Question 46, we have an office supply store selling boxes of pencils, and each box contains 160 pencils. We need to write an equation that represents the total number of pencils Y in X boxes. So for this one, it's very easy to mess up the equation if you're not careful. So what you want to think about, or you could actually write this down. So we don't even need to think about this. Let's just write this down, is that if we have X boxes of pencils, so X is the number of boxes and Y is the number of pencils. So think about if you bought 1 box of pencils, then you would have 160 pencils because there's 160 pencils in each box. If you bought 2 boxes of pencils, then you would double this. You would have 320 pencils. 3 would give you 480. 4 would give you 640, and so on like this. So now this will help you set up your equation, because if your equation is wrong, it's not going to satisfy this table that we just made. So y is the bigger amount. Y is the big number. So x is going to be the one that gets multiplied by 160. So our equation would be y equals 160 times x. This would definitely check out here, because if you think about it, let's say I plugged in here 160 times 3 would give me 480, and this pattern would continue all the way down. So this equation is good. So now for the final part of this question, if x equals 12 for 1 day of sales, we're going to use our equation to find the total number of pencils that the supply store sells. So x equals 12, if we plug that into our equation, is going to give us y equals 160 times 12. So now let's just work this out. We're going to do 160 times 12, and I could use a calculator for this, but let's just work this out. 2 times 0 is 0, 2 times 6 is 12, carry the 1, 2 times 1 is 2, plus 1 is 3. I'm going to put a 0 as a placeholder. We got 1 times 0, 1 times 6, and 1 times 1. And now just add this up, and this is going to work out here. We're going to have 1920. The store is going to sell 1920 pencils if they sell 12 boxes.